And let's first begin with the left side. So the left side, we can use the product of the sum and difference of two terms formula. So this is equal to 1 minus. Actually, let's begin with this factor. So 1 minus the sine square beta is equal to cosine square beta, right? Because the right side just involves the cosine. Okay, so we try to convert the sine to the cosine. So this part, let's begin with the fundamental identity. Then for this part, we get the cosine square of beta. And times the 1 plus the sine square of beta. And to get an expression only involving the cosine, we may replace the sine square beta by 1 minus the cosine square of beta. Right? So now you get 1 plus and 1 minus the cosine square of beta. Then you get cosine square of beta times 2 minus the cosine square of beta. And then you multiply this out, you get the 2 times cosine square of beta and minus cosine to the 4th power of beta. And this is exactly the right side. Then we finish the proof of this problem. Now let's look at the problem 90 on the page 525. And this is a tricky one. And we need to prove this equation is an identity. 1 minus the 2 times cosine square y over the 1 minus 2 times cosine y times sine y equal to sine y and plus cosine y over the sine y minus the cosine y. So let's begin with the left side. And before, we always use the fundamental identity in such a way we replace sine square y plus the cosine square y by 1, right? So whenever we see the sum of these two squares, we replace it by 1. Now, we will apply this fundamental identity in the reverse. Here, I try to replace this one by sine square plus cosine square. So now this one is equal to sine square y plus cosine square y, and then minus the 2 times cosine square y. And do the same thing for the denominator. Replace this one by sine square y plus cosine square y minus 2 times cosine y and times the sine y. Because when I replace this one by the sine square y plus the cosine square y. Then in the denominator, I got a perfect square trinomial, right? So right now you may use the square of the binomial formula. Then you get the square of the sine y minus the cosine y, right? And then for the numerator, cosine square minus 2 times cosine square, you got negative cosine square y. Now let's continue to fact this numerator. You have the sine y minus the cosine y times the sine y plus cosine y. And then you can cancel the common factor of sine y minus cosine y from the numerator and denominator. Then you get sine y plus cosine y over sine y minus cosine y. And this is the right hand side. So in such a way, we finish the proof of this problem. Kind of tricky, right? Especially here, we apply this fundamental identity in the reverse. So before, we always try to simplify the problem by replacing the sine square plus cosine square by 1, right? But right now, we do the reverse. Okay, we replace the 1 by this sine square plus cosine square. Now let's look at the 94. Let me copy this problem on the whiteboard.